We are doing the last 5 problems out of review packet number 2. All 5 of these are short answer, so they take a lot of work to get done. Number 71. Jacob and Zachary go to the movie theater and purchase refreshments for their friends. Jacob spends a total of $18.25 on 2 bags of popcorn and 3 drinks. Zachary spends a total of $27.50 for 4 bags of popcorn and 2 drinks. Write a system of equations that can be used to find the price of 1 bag of popcorn and the price of 1 drink. Using these equations, determine and state the price of 1 bag of popcorn and the price of a drink to the nearest cent. So we need to make our own let statements because they don't do them for us. I'm going to use X and Y because I think they're easier than using the letters because sometimes we can get confused if that's a number. So I'm going to say X is the cost of popcorn, because that's what we're talking about here, is the cost of 1 bag of popcorn and the cost of 1 drink. And Y is the cost of a drink. So back in my problem, it said that Jacob bought 2 bags of popcorn, so 2 bags times whatever they cost, and 3 drinks, so 3 drinks times whatever they cost, and he spent $18.25. Then it says Zach bought 4 bags of popcorn and 2 drinks and spent $27.50. Now it's a system of equations, so we either have to use substitution or elimination to solve it. Either one will work, but a lot of times these ones are best set up for elimination. When you have the numbers and the letters all lined up like that, we are best set up for elimination. Remember, with elimination, you just want to multiply one or both to get the same number, but different signs. So if I multiply this whole equation by -2, I get -4x minus 6y equals -3650, and you can do that right in your calculator. And now look, 4x, 1's negative, 1's positive. So if I rewrite this equation without changing it right below it and add these two equations together, my 4x's cancel. -6y plus 2y is -4y. -3650 plus 2750 is -9. Divide both sides by -4, and I get y equals 225. So that is the cost of 1 drink, because that's our y value. Now we need to find our x value. Our x value, we can just use our y in one of our original equations. I'm going to use this one since it's right here. So 4x plus 2 times 225, because I know that that's what y is now, equals 2750. 4x plus 450 equals 2750 minus 450 from both sides. We get 4x equals 2750 minus 450 is $23, and divide both sides by 4, and you get x is $5.75. So popcorn costs $5.75, and you can box that in as your answer up there. Number 73. I'm just going to slide these up so you can see the whole number 73 when I do the work for it. So number 73 says an animal shelter spends $2.35 per day to care for cats and $5.50 per day to care for dogs. Pat noticed that the shelter would spend $89.50 caring for cats and dogs on Wednesdays. Write an equation to represent the possible number of cats and dogs that have been at the shelter on Wednesdays. So just asking us to write one equation. So I'm going to say, let x equal cats and y equals dogs. If I know that it costs $2.35 to care for a cat times the number of cats we have, and then $5.50 per dog times the number of dogs we have, that would give us our total of $89.50. Then the problem says, Pat said there might have been 8 cats and 14 dogs. Are Pat's numbers possible? Well, cats are X, so if I do 235 times 8, and the dogs were Y, so times 14 equals 8950. You can go to your calculator and do 235 times 8 plus 550 times 14, and we get 9580. Does 9580 equal 8950? No. So no, Pat's numbers are not possible. It says, later Pat found a record showing there was a total of 22 cats and dogs. So our cats plus our dogs, because remember this is the number of each, has to equal 22. How many cats were at the shelter on Wednesday? So now we want to treat this like a system of equation. We want to use this equation and this equation together to do something. Well, we want the number of cats, so we want to eliminate the dogs out of the equation. So I'm going to use my elimination method to get rid of my y's. So I'm going to multiply this equation by negative 5.5. When I do that, I get negative 5.5x minus 5.5y. And when I do negative 5.5 times 22, we get negative 121. And I'm going to add that to this equation up here. If I do negative 5.5 plus 2.35, we get negative 315x. My y's will eliminate from each other like we wanted them to do. And that negative 121 plus 8950 is negative 3150. Divide by negative 315. And we get x equals 10. So there was 10 cats at the shelter on Wednesday. On to the next page. Number 75 says, at Bea's Pet Shop, the number of dogs D is initially 5 less than twice the number of cats C. If she decides to add 3 more of each, the ratio of cats to dogs will be 3/4. Write an equation or system of equations that can be used to find the number of cats and dogs Bea has in her pet shop. Could Bea's Pet Shop initially have 15 dogs and 20 cats? Explain your reason. Determine algebraically the number of cats and the number of dogs Bea initially had in her pet shop. So this one is much more detailed than what we have done in class this year. The main thing I want you to get out of this one is actually just writing this equation right here. I just want you to focus on writing an equation. I put this one in here just to practice writing equations. So it says, at Bea's Pet Shop, the number of dogs D is, so D is 5 less than twice the number of cats C. Well, remember, 5 less than means minus 5, and then twice the number of cats C. Okay? So we're just going to leave that like that. Number 77. At the present time, Mrs. B's age is 6 years more than 4 times her son's age. 3 years ago, she was 7 times as old as her son was then. If B represents Mrs. B's age now and S represents her son's age, so they're giving us the let statements right here. We can't make up our own letters. Write a system of equations that can be used to model this scenario. So at this time, Mrs. B's age is, so her age, well, she's B, is 6 years more than 4 times her son's age. So 6 more than 4 times her son's age. 3 years ago, she was, so again, she is equal to 7 times as old as her son was then. So 7 times what her son is. So that's our systems of equations. Then it says, use this system to determine algebraically the ages of both Mrs. B and her son. So, again, we could use elimination, but because we have B equals, I'm going to substitute this into that one. So 7s equals 4s plus 6 minus 4s minus 4s. We get 3s equals 6. Divide by 3, and we get s equals 2. I need to solve for B, for Mrs. B. B equals 7s. B equals 7 times 2. B equals 14. Those are not their ages, though. At the present time, Mrs. B is 6 years more than 4 times her son's age. So what we need to do, it says determine how many years from now Mrs. B will be 3 times as old as her son will be then. Again, this is like this one up here. I'm not going to go into details with this one. I just wanted you guys to focus on doing the substitution method here with solving the 2 equations. I wanted you to be able to set up equations and then do the substitution method. Okay, we have one more to go. Number 79. Dylan has a bank that sorts coins that are dropped into it. A panel on the front displays the total number of coins inside as well as the total value of the coins. The panel shows 90 coins with the value of $17.55. If Dylan is only collecting dimes and quarters, write a system of equations in 2 variables or an equation in 1 variable that could be used to model this situation. So this is like we did before. I'm going to call dimes X and quarters Y. It says the panel shows 90 coins total. So remember I told you before, total has to equal total. So his dimes plus his quarters has to total 90, and then money has to equal money. Well, dimes are worth 10 cents, quarters are worth 25 cents, and they total up to $17.55. So there's our 2 equations. So it says write a system of equations in 2 variables. It says use your equation to determine the number of quarters Dylan has in his bank. So I want quarters, so I'm going to make dimes eliminate. So I'm going to multiply this one by negative 0.10. So when I do that, I get negative 0.10x minus 0.10y equals negative 9. These eliminate when I add these 2 lines together now. 0.25 minus 0.1 gives you 0.15y, and 1755 minus 9 equals 855. Divide by 0.15. We get 57. So that means he has 57 quarters in his bank. That answers that question. So it says, Dylan's mom told him that she would replace each one of his dimes with a quarter. If he uses all of his coins, determine if Dylan would have enough money to buy a game priced at $20.98 if he must also pay 8% tax. So we need to figure out how many dimes he has. Well, that's easy. X plus Y equals 90. If I know I have 57 quarters, I can plug that in for the Y. Subtract 57 from both sides. 90 minus 57 tells me that he has 33 dimes. So his mom is going to turn them into quarters for him. It says Dylan's mom told him she would replace each one of his dimes with a quarter. So these 33 dimes are now going to become quarters. So technically, he's going to have all 90 of his coins be quarters, because we have the 57 quarters here and now these 33. So how much money would he have? Well, 90 quarters times 0.25, what each quarter is worth, gives us $22.50. They want to know, oops, sorry, I didn't realize that you were running out of room. Let me move this up. There we go. So the 90 times the 25 cents gives us that. So we need to see if he has enough money. Well, the game is $20.98 times 0.08 sales tax. So $20.98 times 0.08. So he's going to pay $1.68 in tax on the $20.98. So it'd be $22.66. Does he have enough money to buy his video game if he only has $22.50? No, he cannot buy the game. He technically only needs another 16 cents, but the store is not going to give him that 16 cents. It is your job to now try numbers 72 through 80 evens. Give them your best shot. I know these are the harder ones. Some of them I just care that if you can set up the equation.